everyone, I Dr. Indu TK and you have been watching my series on Geography of India. Today we are going to explore the amazing world of soils in India. Soils are essential for growing our food, supporting plants and animals and keeping our environment healthy. By learning about the different types of soils in India and their importance, we will see how they help us and our planet. Let's get started and discover what below our feet. Soil is the top layer of the earth crust. It forms from the weathering of rocks and is influenced by factors like climate, vegetation and the type of rock underneath. In simple terms, soil is much more than just dirt. It's a vital and dynamic resource that supports all life on earth. India, with its vast size and diverse geography, has a wide range of soil types. Each type is unique and shaped by the local environment. From the fertile plains to the arid desert, our soils are essential for growing crops, supporting plants and animals, and maintaining health of our ecosystem. Understanding these different soil types help us appreciate the natural richness of our country. It also guides us in making better agriculture choices and managing our land sustainably. So, let's embark on this journey to uncover the various soil types of India and see how they contribute to our environment and economy. But first, let's understand into the basics of what soil is and why it's so important. What is soil? Soil is the upper layer of the earth's surface that serves as a natural medium for plant growth. It is a dynamic and complex mixture that includes several key components. Let's break down the components that make up soil. First one is minerals. They are tiny particles that come from the weathering of rocks. They are classified into sand, silt and clay based on their size. Next one is organic matter. This consists of decomposed plant and animal material. It enriches the soil with essential nutrients and improves its structure. Next one is water. Soil retains water which is essential for plants. It also helps in dissolving nutrients so that plants can absorb them. Next one is air. The space between soil particles contain air which is crucial for root, respiration and survival of soil organism. Next, let's explore the key factors that contribute to soil formation. First one is parent material. This is the underlying geological material from which soil is formed. It can be bedrock, volcanic ash or sediments deposited by wind, water or ice. The mineral composition and texture of the parent material significantly influence the soil properties. For example, soil derived from limestone and typically rich in calcium, while those from granite might be sand and acidic. Second factor is climate. Climate plays a crucial role in soil formation. Temperature and precipitation determine the rate of weathering of the parent material and the organic matter decomposition. In warm, wet climates, the chemical weathering is more intense, leading to the formation of deep fertile soils. In contrast, cold or arid regions may have slower soil formation and shallower, less fertile soil. The third factor is organisms. Living organisms including plants, animals and microorganisms are vital contributors to soil formation. Plants contribute organic matter through their roots and leaf litter which decompose to form humus. Microorganisms break down organic matter and release nutrients enhancing soil fertility. Burrowing animals like earthworms and insects aerate the soil and mix organic and mineral components, improving soil structure. Next factor is topography. The landscape topography or relief influences soil formation by affecting drainage, erosion and sunlight exposure. Soils on steep slopes are often thinner and less developed due to erosion, while those in valleys may be deeper and more fertile due to the accumulation of materials. South-facing slopes in the northern hemisphere receive more sunlight, leading to different vegetation and soil types compared to north-facing slopes. The next factor is time. Time is a crucial factor in soil formation. Soil develops over long periods, sometimes thousands or millions of years. The length of time a soil has been forming affects its depth, structure and composition. Younger soil found in recently formed landscape may be less developed and more influenced by their parent material, while older soils have undergone more extensive weathering and organic matter accumulation. The next factor is human activity. Human activities significantly impact soil formation and development. Agriculture, deforestation, urbanization and pollution can alter the natural process of soil formation. While some human activities like sustainable farming practices can enhance soil health, and others such as overgrazing and industrial pollution can degrade soil quality and reduce its fertility. Next, we will discuss soil profile of India, focusing on three main layers or horizons that make up the soil structure. Each horizon play a crucial role in supporting plant growth and contributing to soil fertility. Let's explore these horizons in detail. Horizon A, the topmost layer, is known as topsoil. This is the uppermost layer of the soil profile and is incredibly important for plant growth. Horizon A is rich in organic materials which are decomposed remains of plants and animals. These organic materials mix with the mineral matter, creating a fertile environment. This layer also contains essential nutrients and water which are necessary for their healthy growth of plants. The color of horizon A is usually darker than the layers below due to the high organic content. Plants establish their roots in horizon A, drawing nutrients and moisture necessary for growth. This layer is critical for agriculture as it directly affects crop yield and soil health. The next horizon is horizon B, the transition zone, which is the middle layer acting as a transition zone between horizon A and horizon C. Horizon B contains materials derived from both above and below. This includes organic matter from horizon A and material matter from horizon C. The mineral matter in this horizon is more weathered compared to horizon C, indicating ongoing soil formation process. While it has some organic matter, it is less than what is found in horizon A. Horizon B plays a crucial role in soil structure as it helps in the upward and downward movement of water and nutrients. It provides a buffer zone that supports the overall soil ecosystem, ensuring stability and continuity in nutrient cycling. Next is horizon C, the parent material. It is the bottommost layer, also known as the parent material. Horizon C is composed of loose parent material which can be rock fragments, sand, clay or other geological deposits. This layer represents the initial stage of soil formation and contains minimal organic matter. Over time, weathering process break down this material, contributing to the formation of the upper horizons. Horizon C is essential for soil formation process. It eventually breaks down to form horizon A and B. This layer provides the minerals that become available to plant as the soil matures and develops. By understanding these horizons, we gain insight into soil formation process and the factors that support plant growth. This knowledge is crucial for sustainable land management and agriculture practices. Next, we will explore the diverse soil types found across India. The country's varied relief features, climatic condition and vegetations have led to the development of multiple soil types, each with unique characteristics. Based on their genesis, color, composition and location, the soils of India can be classified into 8 major types. Let's explore into these soil types in detail. First one is alluvial soils. Alluvial soils are the largest and most significant soil group in India, covering about 15 lakh square kilometers or 45.6% of our land area. They are vital for agriculture. They are primarily formed by the sediments deposited by the rivers, especially in the Indo-Gangetic plain. Some coastal alluvial soils are formed by sea waves. They are rich in nutrients but often lacking in nitrogen, phosphate and humus, and it is highly fertile and support a wide range of crops. The major crops are rice, wheat, sugarcane, cotton, jute, potato and vegetables. Alluvial soils are mainly found in the floodplains of Satluj, Ganga and Brahmaputra rivers, as well as the valleys of Narmada, Tapti, Mahanadi, Godavari, Krishna and Kaveri. The major types of alluvial soils are: the first one is Khadar, the New Year alluvium found in low-lying areas flooded annually. The second type of alluvial soil is Bangar. The older alluvium found at higher elevation contains clay and lime nodules called Kankar. Next one is Babar. Babar alluvial soil found along the Shivalik foothills. And the next type is Tarai, swampy lowland south of the Babar, rich in nitrogen and organic matter. The second type of soil is red and yellow soil, found in various parts of India including Tamil Nadu, Karnataka, Maharashtra, Madhya Pradesh and northeastern states. They are rich in iron but low in nitrogen, phosphorus and organic content, varies from loam to clayey loam. They are mainly suitable for ragi, groundnuts, millets, tobacco and potassium crops. They covers about 29.08% of India's total soil cover. Next type is black or regger soil. Named for its black coloration and suitability for cotton cultivation, this soil type is vital for agriculture in India. They are formed from the solidification of lava during the volcanic activity in the Deccan Plateau. They have high water retention capacity, become sticky when wet and develops deep cracks during dry season, aiding soil aeration. They are mainly ideal for cotton but also support cereals, oil seeds and pulses. They are predominantly found in Maharashtra, Madhya Pradesh, Karnataka, Andhra Pradesh, Gujarat and Tamil Nadu. The next type of soil is desert soil, found in arid and semi-arid regions such as western Rajasthan, southern Haryana and southwestern Punjab. The main characteristics is it is sandy to loamy, pale brown to yellowish brown, low in nutrients and water holding capacity. It is limited to drought resistant crops. Irrigation can support crops like wheat and millets. And the next important soil is laterite soil, formed in the tropical regions with alternating wet and dry climates. These soil are rich in iron and aluminium. The main characteristics of this soil are they are very low in calcium and magnesium and they are porous and well drained. Mainly suitable for plantation crops like tea, coffee, cashew and rubber. These soils are mainly found in Karnataka, Kerala, Madhya Pradesh, Maharashtra, Orissa, Assam and Tamil Nadu. The next important soil type is mountain soil, mainly found along the slopes of mountains and hills. These soils vary greatly depending upon the region. They are dark brown clay slate to loamy texture, slightly into moderately acidic, high humus content and fertile. And they are ideal for tea, coffee, spices and tropical fruits. They are predominantly found in Jammu Kashmir, Himachal Pradesh, western Ghats of Karnataka, Kerala and Tamil Nadu. The next type of soil is alkaline and saline soil. These soils are found in arid and semi-arid regions and are often fertile. They are sandy to loamy texture, high salt content and low water retention capacity. High pH making them unsuitable for most crops without significant amendments. They are mainly found in Rajasthan, Punjab, Uttar Pradesh, Haryana, Gujarat and Maharashtra. And the last important soil type is peaty soil. Formed in hot, humid condition with high organic matter accumulation, these soils are dark and highly acidic. They are high organic content, low in phosphorus, high in soluble salt, very acidic with pH below 3.5 to 4. These soils are mainly found in Orissa, West Bengal, Sundarban, parts of Bihar, Uttar Pradesh and Kerala. Next, we will be discussing a crucial topic concerning the environmental and agriculture sustainability in India, the problems faced by Indian soil. Soil is fundamental to agriculture and ecosystem health, but various issues are impacting its quality and productivity. First one is soil degradation. One of the primary problems is soil degradation. This occurs due to factors like erosion, salinization and loss of soil fertility. Intensive farming practices, deforestation and improper land use contribute to soil degradation, reducing its ability to support crops. Next one is soil erosion. Soil erosion is a significant issue in India, especially in hilly and mountainous regions. Factors such as deforestation, overgrazing and poor land management lead to the removal of topsoil which is rich in nutrients. This loss affects the crop yields and can lead to the degradation of agricultural lands. Next one is soil salinization. Soil salinization is another serious problem, particularly in irrigated areas. The accumulation of soluble salt in the soil reduces its fertility and can render it unsuitable for crop growth. This issue is often exacerbated by poor irrigation practices and inadequate drainage. Next one is soil pollution. Soil pollution is a growing concern in India caused by the indiscriminate use of chemical fertilizers, pesticides and industrial waste. Contaminants in the soil can affect plant health, crop safety and ultimately human health. Addressing soil pollution requires better management practices and regulation. Next one is loss of soil fertility. Loss of soil fertility is linked to the depletion of essential nutrients due to continuous cropping without adequate replenishment. Over-reliance on chemical fertilizers and inadequate organic matter addition can degrade soil health over time. Next one is desertification. Desertification is a process where fertile land becomes desert as a result of various factors including prolonged drought, deforestation and unsustainable land use practices. This phenomenon affects large areas in India, particularly in arid and semi-arid regions. Next one is solution and strategies. Addressing these soil problems requires a multifaceted approach, and the solution include: the first one is adopting sustainable farming practices. Implementing crop rotation, agroforestry and organic farming can help maintain soil health. The second important thing is improving irrigation techniques. Using the efficient irrigation system and managing water resources better can reduce salinization. Third one is reforestation and afforestation. Planting trees and restoring forests can prevent erosion and improve soil structure. Fourth one is soil conservation and measures. Techniques like terracing, contour plowing and maintaining ground cover can help to reduce erosion. Next one is regulating chemical use. Reducing the use of harmful chemicals and promoting integrated pest management can mitigate soil pollution. It is evident from the foregoing discussion that the variety and the quality of soil across India are crucial to health of our ecosystem and the productivity of our agriculture. Soils are not just passive substrates but dynamic living systems that evolve over time. Their health impacts not only the growth of plants and crops but also broader environment and our livelihoods. Proper management and conservation of our soil resources are essential to ensure their continued fertility and sustainability. By understanding and respecting the vital role that soil plays, we can make informed decisions to preserve and enhance this invaluable resource for future generations. Thank you for exploring the fascinating world of soil with me today. Have a great day.